Hello guys, for the last few days, I've been testing one of Microsoft's most hyped features, and that is AutoSR. AutoSR stands for Automatic Super Resolution, and basically, this is Microsoft's answer to traditional upscalers like FSR, RSR, DLSS, XESS, and even third-party ones like Lossless Scaling. But there is one big difference here. This time, the upscaling is done using the NPU. And honestly, that sounds really fascinating at first. Because for a while now, we've had these NPUs inside the chips, but when it comes to most cases, including gaming, they were just sitting there doing nothing. And on paper, this sounds like the dream. Better image quality, better performance, and finally less load on the GPU thanks to having an AI-driven chip that is going to process all of that. But sadly, after testing it properly, that dream started to fall apart. I did multiple comparisons across multiple games, different power modes, comparing image quality, checking performance statistics like FPS, frame time, CPU clocks, GPU clocks, and even FPS per watt. The results were not what I expected at all. Visually, AutoSR can look genuinely impressive, but performance-wise, that's where things can get very bad, and I really mean it. To the point that made me question what is really happening under the hood. So in this video, I'm gonna try my best to answer that by going deep into AutoSR on the ROG Xbox Ally X. We're going to look at what improves, what it costs in performance, how the NPU behaves, why performance can actually get worse, and whether AutoSR is something you should actually use right now. So with that being said, get yourself ready for a proper deep dive with me into this. First, let's quickly talk about the test setup I have. Here on my ROG Xbox Ally X, I have all Armory Crate updates installed, and I'm currently running BIOS 317. For power modes, I tested at 17 watts, which everyone including Asus considers the sweet spot for performance and efficiency, and probably the most realistic power target for gamers using the ROG Xbox Ally X. But I also tested at 35 watts, which is the maximum performance mode, because I wanted to see if AutoSR behaves differently when the device has more power available. I also have OS power mode set to performance. Fans speed is fixed at maximum just to avoid performance variation caused by thermal inconsistency. GPU VRAM is set to the default 8GB, and all AMD GPU features are disabled. So no RSR, no AFMF, no Radeon anti-lag to avoid any kind of interference with the outcome. CPU boost is enabled, and the CPU core configuration is left at default, with all P and E cores enabled. So the idea here is simple. Keep the test environment as clean as possible and let AutoSR be the main variable. Now that we have the setup out of the way, let's talk about how AutoSR actually works right now. Currently, AutoSR is only available if you are enrolled in the Xbox Insider program. So inside the Xbox app, you need to join the Insider program to receive the update that enables AutoSR. Once you have it, if you press the Xbox button on the ROG Xbox Ally X and go into Display Settings, you will find AutoSR listed there, currently still in preview. From there, you can enable AutoSR per game. Once you enable it for the first time, it asks you to restart the game so it can apply. You can also enable an indicator here that shows when AutoSR is actually running, kind of like an overlay. And this indicator could be actually very important because AutoSR doesn't just work in every situation. Like in my case, for example, despite enabling it first and restarting the game, AutoSR still didn't work. And the reason was because my in-game resolution was set to 1080p. As you can see, here they say that AutoSR currently only works between 720p and 900p because the feature is designed to target lower resolution and upscale them. So once I lowered the game resolution to 900p, Auto SR immediately turned on, without even needing another restart. And you can see it right here with the indicator. At just first glance, looking at the game menu, you can immediately feel the difference when Auto SR is on versus off. The image looks cleaner, sharper, and more refined. It honestly makes a pretty noticeable difference in terms of image fidelity and clarity, without looking fake or overly sharpened. But there's a catch, actually more than one. Right now, Auto SR only works when the device is connected to power. So you need to have the unit plugged into a power source through a docking station ideally. And by the way, I already talked about some suitable docks for the ROG Xbox Ally X in a previous video, which you can check out here. But basically saying Auto SR requires that. And not only that, it only works on external display right now, because according to Microsoft, Auto SR is currently oriented around docked usage, where you can connect the device to a bigger external display and use upscaling to get a cleaner image while still trying to maintain suitable performance using the NPU. So for now, Auto SR is clearly being pushed more as a docked external display feature. Before jumping into the performance numbers, I wanted to first prepare some image comparisons because visually Auto SR is actually very interesting and I actually want you to see it for yourself just how amazing it is. For the image quality comparison, I tested 4 setups. Auto SR off at native 900p, Auto SR on at 900p, FSR quality at 900p, and native 1080p. This way, we can compare Auto SR not only when it's turned on versus off, but also against a commonly used upscaler like FSR, and against also a native 1080p as a higher fidelity reference point. Keep in mind for FSR quality, I left the sharpness at the default value, which is 30%. So now I let the images roll and you can judge for yourself. Pay attention to specific areas like edges, grass, fine details, and overall image stability. And let me know in the comments down below which one you think looks the cleanest without looking overly artificial. Alright, now let's roll the comparisons. So here I am back. In my opinion, AutoSR does an awesome job at refining a native 900p image. It looks significantly cleaner and sharper, but without looking overly processed. And that's what surprised me the most. With FSR, as we all know, sometimes the image can feel a little bit frizzy or too artificial and sharp, especially around the grass, small details like light bars in case of Cyberpunk, fences, or anything with a lot of thin edges. But with AutoSR, I didn't really feel that in the same way. It feels cleaner, but still not fake. And in some scenes, AutoSR at 900p even looked better to my eyes than native 1080p. So from an image quality perspective, AutoSR is genuinely doing something interesting. But image quality is only one side of the story. Because once we move into performance, things get more complicated and terrible. And now, this is exactly where our video really starts. For the performance testing, I keep the same 4 setups. AutoSR off at native 900p, AutoSR on at 900p, FSR quality at 900p, and native resolution 1080p. I tested 6 games across 2 power settings, 17 watts and 35 watts, so we can get a broader picture of how AutoSR behaves in different scenarios. And I didn't want to look at FPS only. I wanted to cover this in a much deeper way, because with a feature like AutoSR, FPS alone doesn't tell the full story. So alongside FPS, I also looked at frame time, CPU clocks, GPU clocks, NPU usage, NPU power, and FPS per watt for efficiency comparison. This way, we can see not only whether AutoSR is faster or slower, but also what might be causing that behavior under the hood. Starting with Cyberpunk 2077 at 17 watts, on the overlay, as you can see, I included the NPU matrix. We have here NPU usage, NPU clock, and NPU power usage. And you can clearly see that in all non-AutoSR setups, the NPU is completely flatlined at 0. But with AutoSR on at 17 watts, we can see decent NPU usage. The good thing is that the NPU itself is generally very efficient. It barely consumes around 1 watt. And in this 17 watt test, the NPU clock was sitting around 1150 MHz. Later on, we'll see that the NPU gets actually a decent boost at 35 watt power mode. Now, if AutoSR is using the NPU and the NPU is barely consuming power, you would expect performance to improve, right? That's what I expected to, but that's not what happened. In Cyberpunk, AutoSR on actually falls behind quite heavily. FSR quality at 900p is higher by around 25 FPS on average, while AutoSR off at 900p is also higher by around 15 FPS. So enabling AutoSR gave us a significant performance hit. And honestly, this was the first result that made me stop and think, because AutoSR was even worse than native 1080p in this test. At first, that didn't really make sense to me, and honestly, it made me question whether I was doing something wrong in the test. Because we enabled the NPU, and the whole idea is that the NPU should help with the upscaling, reducing some load off the GPU. But instead, performance has dropped. So what is actually going on here? Well, it turns out that even if the NPU is doing the upscaling, the CPU and GPU are not completely out of the equation. The GPU still has to render the frame first. Then, that frame has to move through memory or the internal pipeline. The NPU then has to process or upscale it. And after that, the processed frame still needs to go back through the output path to the display. So yes, the NPU is helping, but it doesn't mean the rest of the components gets a free pass. Everything still has to work together. And that kind of movement between the GPU, memory, NPU, CPU, and display pipeline can create extra overhead. That kind of overhead could be one of the reasons why performance has dropped, even though the NPU itself is efficient. But beyond that, it also seems like enabling Auto SR changes completely how the CPU, GPU, and basically everything behave. And we'll see that clearly in a moment when we start looking deeper into the hardware matrix. Looking at the frame time, we can see the lead that FSR quality has. While Auto SR on has higher frame times and more frequent spikes, sometimes going toward 40 ms or more. And frame time is very important here because FPS tells you how many frames you get, but frame time tells you how smooth those frames actually feel. Lower and more stable frame time usually means a smoother experience, while higher spikes usually means stutter, inconsistency, or worse pacing. And then again, looking at the percentile line, the same behavior is visible. So I started looking deeper into what was happening under the table. And one of the first things I noticed is that enabling Auto SR caused a noticeable decrease in CPU clock. With Auto SR on, the CPU seems almost stuck at around 2200 MHz, even with CPU boost enabled. Meanwhile, the other setups are generally higher by around 300 to 400 MHz. And if that was bad news, the GPU clock was even worse. With Auto SR on in Cyberpunk at 17 Watt, the GPU clock was around only 800 MHz, while the other setups were higher by roughly 200 to 300 MHz. So losing those critical CPU and GPU clocks at this low already TDP is probably one of the main reasons behind the degraded performance. I'm not entirely sure what the exact reason is, but there are a few possible explanations. It could be that the communication between the NPU and the other parts of the APU needs to happen in a specific way, and that extra coordination may be affecting how the CPU and GPU behave. It could also be power related, since the CPU, GPU, NPU, and SOC are all sharing the same limited power budget. Enabling Auto SR may shift more of that budget towards the NPU and the SOC side, leaving less headroom for the actual CPU and GPU cores to boost as high. Or it could also be latency related, where the NPU processing adds extra delay into the frame pipeline, and the other components end up waiting for that process to finish. Either way, something is definitely going on. Looking at the NPU usage, Auto SR was averaging around 80% usage at 17 Watt. Now you can see that the NPU power itself was less than 1 Watt. On the overlay, it barely showed as 1 Watt, but when we look at the graph in more detail, it's closer to around 0.5 Watt. But then something really caught my attention, which is SOC current. Now before looking at the number, let me quickly explain what that means, because this is actually important. The SOC, which stands for System on Chip, is basically the part of the chip that connects and manages many of the components around the APU. So we are talking about things like memory communication, display output, media engines, the NPU itself, and the internal data movement between different parts of the APU. In simple words, it's not just CPU or GPU power. It's more like the shared system area that helps all these different blocks talk to each other and move data around. And current, measured in amps, is how much electrical flow that part of the chip is pulling. Power, measured in watts, is the actual energy being consumed. So when both SOC current and SOC power go up, that usually means this part of the chip is doing more work. And this is exactly what I saw with Auto SR on. In the other runs, SOC current was around 2 amps, but with Auto SR on, it jumped to around 6 amps. This is roughly 3 times higher. And honestly, that caught my attention because we mainly enabled Auto SR, which uses the NPU. So why would SOC current jump that much? My theory is that Auto SR is not only using the NPU itself, it may also be increasing load on the whole SOC fabric around it. Because remember, the GPU still renders the game first, then the frame likely has to move through memory or the internal display pipeline, then the NPU has to process or upscale that frame. And after that, the processed frame still needs to be sent back through the output path to the display. So even if the NPU itself only consumes around half a watt or 1 watt, the data movement around the NPU may still cost extra power. And that could explain why the NPU power looks low, but the SOC current and SOC power increase much more noticeably. This could also explain why CPU-GPU clocks dropped with AutoSR on. On a handheld APU, everything is sharing a limited power and thermal budget. So if the SOC side starts pulling more power, the other parts may have less headroom to boost as high. And if the frame has to wait for the NPU or the internal pipeline, that could also explain the worse frame pacing. Higher current by itself doesn't automatically mean there is a problem. The chip is designed to manage power dynamically, but what I'm trying to say here is that AutoSR clearly changes the behavior of the whole APU. It's not just a free NPU upscaler running in the background. It seems to add extra work to the SOC side, and that extra work may be part of the reason why performance and efficiency took a hit. SOC power draw also increased by around 2 watts, as you can see here in the graph. And that makes the result even more interesting, because the NPU itself is not consuming much, but the surrounding system seems to be working harder. And if that wasn't enough, I also noticed a significant change in CPU wait average time. In this case, lower is better because higher wait time means the CPU is waiting longer for the frame to be rendered or completed. And with AutoSR on, CPU wait average time increased quite significantly, probably due to the NPU processing the add pipeline delay. Finally, looking at the FPS per watt at 17 watt in Cyberpunk 2077, FSR quality is our best result, getting around 4 FPS per watt. AutoSR off at 900p comes in second place at around above 3 FPS per watt. Now native 1080p is around 2.7 FPS per watt, and finally AutoSR on at 900p comes in last at around 2.4 FPS per watt. And FPS per watt is important because it shows performance efficiency. For a limited powered handheld, it's quite crucial knowing about how many frames we get for the power we are spending. It really matters a lot here. So already from the first game, we can see the trade-off clearly. AutoSR improves image quality, but it also changes the behavior of the chip in a way that hurts performance and efficiency. Now moving on to our second game, Forza Horizon 5 at 17 watts. And this is where things get even more surprising. This time, the base setup is AutoSR off at 900p, with FSR quality very close behind, and native 1080p also not too far away. But AutoSR on at 900p is way far behind. In fact, performance was down by around 50%. That is honestly mind-blowing. Frame time pacing is also way worse. All the other setups have much better frame time values, while AutoSR on is almost double in some cases. Again, I noticed a very inconsistent CPU clocks with AutoSR on. You can clearly see the fluctuations happening here. It's the lowest and least steady setup, showing strange ups and downs. The GPU clock is also lower than the rest by around 200 MHz. In this title, NPU usage was generally higher and more stable with AutoSR, which is actually a good sign. It means that AutoSR was using the NPU more consistently. NPU clock was also higher than what we saw in Cyberpunk, reaching over 1400 MHz, even with the 17 power cap. But it also consumed slightly more power, around 0.8 watt. And again here, we see higher SOC current compared to the rest. This time AutoSR on reached around 8 amps on average, with highs close to 9 amps. Meanwhile, the rest of the setups were still sitting around 2 amps. That is a huge difference if we just think about it. Sock power draw also increased again. And finally, looking at FPS per watt, the best result is Auto SR off at 900p, followed by FSR quality, and also native 1080p is almost on par, around 6 FPS per watt. But Auto SR on at 900p is around half of that. And honestly, that is horrible sight for something that is supposed to help performance. Now, next game we have is Horizon Zero Dawn. For a bit, I'll increase the pace a little bit here because by now you can already see the pattern forming. The best performance comes from FSR quality at 900p, getting around 79 FPS average with the best low FPS. After that, we have Auto SR off at 900p and native 1080p. And once again, the worst of the bunch is Auto SR on at 900p with around 48 FPS average. Frame time also shows frequent latency spikes hitting the ceiling of 40 ms. So generally, FSR quality is again our best result here. Looking at FPS per watt, FSR quality gives around 4.8 FPS per watt, while Auto SR on is below 3. So we are losing around 1 FPS per watt on average when enabling Auto SR at 900p. Next game is Red Dead Redemption 2. And by now, the trend is pretty clear. FSR quality performs the best, while Auto SR off at 900p is quite close. Auto SR on at 900p is almost on par with native 1080p in this one. So it's not as terrible as some of the previous games, but it's still clearly behind the best setups. The same thing applies to frame time. Auto SR on and native 1080p perform worse by around 10 ms compared to FSR quality and Auto SR off at 900p. FPS per watt is around 4 FPS for FSR quality and almost the same for Auto SR off at 900p. But with Auto SR on, we lose around 1 FPS per watt. Native 1080p comes in around 3 FPS per watt. Next game we have is Monster Hunter Wilds. Now this game is probably a bad example because of its poor PC optimization, as we all know, but I wanted to include it anyway to see how Auto SR behaves in a heavier and less optimized title. And once again, our base setup is FSR quality at 900p, getting around 32 FPS. That's still not exactly playable, but then look at Auto SR on at 900p. It gets around 24 FPS. That's bad on every level and scale. I believe every real gamer watching this would agree with me. It's almost like native 1080p, but with significant spikes and worse frame time. Generally speaking, the game already has bad frame times, with most setups going over 40 ms. But with Auto SR on, frame time gets close to 70 ms and even beyond at times. So in Monster Hunter Wilds, Auto SR really doesn't help the experience. Next game is Shadow of the Tomb Raider. In this title, I didn't find FSR available as an option, so I excluded it from the comparison. But I still wanted to compare native resolution with Auto SR on and off, as well as native 1080p. Here, Auto SR off gets around 81 FPS, but enabling Auto SR loses around 30 FPS. Native 1080p comes in the middle at around 64 FPS. Now frame time is again much worse with Auto SR on, almost double in some cases. So even in this older title, Auto SR still causes a big performance hit. Now that we finished the 17 watt result, let's move into the 35 watt tests. And this is where I really wanted to see if things would change given the fact that we have higher power budget now. So the questions this time are simple. With maximum power, can Auto SR recover in performance? Can the CPU and GPU clocks come back higher? Or does the same issue remain even with more power? So let's find out. Starting again with Cyberpunk 2077 with Auto SR on, as you can see NPU usage increased to around 100% with higher clock. So the NPU is definitely being used more at 35 watt. But performance-wise, the gap is still there. FSR quality gets around 80 FPS average, Auto SR off at 900p comes next at around 75 FPS, and in third place, native 1080p gets around 63 FPS. And finally, Auto SR on at 900p gets around 58 FPS. So even with more power available, we still have around a 20 FPS gap compared to the best setup. Looking at the frame time graph, we again see the difference. Auto SR on has higher frame time spikes going above 30 ms and generally higher than the average of the other setups. FSR quality and 900p with Auto SR off are still the best here. Now I was really curious to see what happens to the CPU and GPU clocks at 35 watts. On the CPU side, the other setups average around 2500 MHz, while Auto SR on is still struggling to keep normal behavior with odd fluctuations and generally lower clocks by around 200 MHz. But it's not a huge problem once you take a look at the GPU clock where the gap is even bigger. The other setups like FSR quality reach around 2500 to 2700 MHz, but Auto SR on mostly stays around 2200 to 2250 MHz. So even at 35 watts, there is definitely something happening here. As we said, the NPU behavior improves at higher TDP. In Cyberpunk, for example, at 35 watt, NPU usage is close to 100%, and the NPU clock hits around 1250 to 1500 MHz, and power goes up to around 1 watt. Of course, given that we are at 35 TDP, so current naturally increases a little bit even for the other setups. Where it was around 2 amps before, now it's slightly higher. But with Auto SR on, it jumps to around 10 amps. So the increase is even more dramatic this time. We are talking about roughly 4 times higher current in some cases. Soak power also increases to around 7 watts. And CPU wait average time still hasn't recovered despite the higher TDP. With the other setups, it's around 0.5 ms, but with Auto SR on, we get spikes around 3.5 ms. Looking at the FPS per watt, naturally for all setups, we'll get lower scores at 35 watt compared to 17 watts, because 17 watts is actually the sweet spot for the Z2 Extreme chip. So FSR quality gets around 2.5 FPS per watt, native 900p with Auto SR off is around 2.1, native 1080p is 2, and Auto SR on is around 1.7 FPS per watt. So even at 35 watts, Auto SR on is still behind in power efficiency. Now moving on to Forza Horizon 5 at 35 watts, and this one is genuinely one of the most shocking results. This time, native 900p with Auto SR off and FSR quality at 900p are all performing around the same level. But Auto SR on at 900p still hasn't improved enough. It loses a whopping 50 FPS compared to the other setups. And honestly, at this point, I just couldn't wrap my head around this level of performance degradation. Frame time is also much worse. So while native 1080p improved nicely with the higher TDP compared to 17 watts, Auto SR on at 900p didn't recover in the same way. It's still bad in terms of frame time and performance. What shocked me the most here is the significantly lower GPU clocks with Auto SR on. You can see dips around 1500 to 1800 MHz, and it only maxes at around 2100 MHz. Meanwhile, the rest of the setups easily stay stable at around 2650 MHz. That is a huge gap, and it could be one of the main reasons why performance is so bad with Auto SR in this game. And this is despite the fact that the NPU clock is actually quite high here, reaching around 1800 MHz. But I also noticed that the NPU consumes more power this time, getting close to 1.8 watt, like almost 2 watts. And also here, this is where the sock behavior becomes really important again. At 35 watts, we naturally expect higher power use overall, but with Auto SR on, the sock current didn't just increase slightly, it jumped massively. In this one specifically, sock power current with Auto SR on reached around 14 amps, while the other setups stayed around 2 to 3 amps. At this point, I honestly lost count of how many times higher that is. 4 times, 5 times, 6 times. Either way, it's a massive difference. And to me, that suggests that AutoSR is probably not only using the NPU core itself, but also pushing the surrounding SOC fabric much harder at this point. And this may be one of the reasons why the GPU clock is so much lower here. So if more of the power budget is being used by the SOC side, the GPU cores may not be able to hold the same high clocks as before. It's all being eaten away from it. SOC power also reached around 13.5 watts, while the rest stayed much lower. Again, CPU wait average time is bad. With AutoSR on, it gets around 8 ms and averages around 6 ms. Meanwhile, the rest are almost 0.1 ms, especially FSR quality at 900p. So naturally, FPS per watt takes a big hit here. Our best run is native 900p with AutoSR off, around 3.5 FPS per watt. FSR quality at 900p and 1080p runs are almost on par. But AutoSR on drops to around 2 FPS per watt. Then we move again to Horizon Zero Dawn at 35 watts. I try again to fasten the pace. This time our highest performing run is FSR quality at 900p, getting around 92 FPS average. Second place is AutoSR off at 900p, around 74 FPS. Native 1080p and AutoSR on are almost neck and neck. The frame time graph shows that AutoSR on and native 1080p are both doing worse with the frame times around 20 ms. Meanwhile, FSR quality and native 900p are closer to 10 ms, so you can clearly see the difference. Looking at GPU clock, AutoSR on still shows some dips below 1800 MHz. On average, it's lower than the rest by around 200 to 300 MHz. So again, not that impressive. FPS per watt is over 2.5 for FSR quality at 900p. The lowest results are AutoSR on and native 1080p, around 1.6 FPS per watt. Next is Red Dead Redemption 2 at 35 watts. FSR quality again takes the crown at around 75 FPS. AutoSR off at 900p follows very closely. AutoSR on the other hand, for the first time, comes in third place at around 59 FPS, so not too bad compared to some of the previous examples. And native 1080p comes in last. Frame time shows that AutoSR on and native 1080p are still lacking compared to FSR quality and AutoSR off at 900p. Checking SOC current again, we see higher current with AutoSR on, averaging around 10 amps and reaching highs of around 12 amps. SOC power draw is also higher again. FPS per watt shows that the difference between the best FSR quality result and AutoSR is around 0.5 FPS per watt. So in Red Dead Redemption 2, AutoSR is not as disastrous, but it's still not the most efficient or best performing option. Then we have Monster Hunter Wilds at 35 watts. FSR quality gives us around 40 FPS. That is still not ideal, but it is still better than 17 watts. AutoSR off comes in second place at around 36 FPS, and AutoSR on improves compared to 17 watt run and comes in third place at around 34 FPS. And finally, native 1080p gets around 32 FPS average, even though it has better 1% loss than AutoSR on. Frame time shows how bad this game behaves across all setups, but FSR quality at 900p is around 20 to 30 ms this time, which is definitely not as bad as Auto SR on. With Auto SR on, frame time still reaches very high values around 70 ms, with an average of around 35 ms. So even though performance improves at 35 watts, frame pacing is still a problem for it. And finally, we have Shadow of the Tomb Raider at 35 watts. As I said earlier, FSR isn't available in this game, so it's not present in this comparison. FPS wise, Auto SR off gets around 83 FPS average with the best low FPS, while Auto SR on at 900p and native 1080p come almost on par. So once again, Auto SR on is not beating native 900p with Auto SR off, and in many cases, it behaves closer to native 1080p in terms of performance cost. So, after all of this testing, I have to say, Auto SR left me pretty shocked. And not because the image quality is bad, actually it's the opposite. Visually, I think Auto SR is genuinely impressive. It can make a 900p image looks cleaner, sharper, and more refined, without looking fake or overly processed. In some cases, I honestly felt it looked even better than native 1080p. But once we move away from image quality and look at performance behavior, the story changes completely. Across all games I tested, enabling Auto SR came with a real performance cost. CPU clock dropped, GPU clock dropped, frame time got worse, CPU wait time increased, and ultimately FPS per watt went down. And the thing that surprised me the most was the SOC behavior. The SOC current and SOC power increased way more than I expected, especially in some games where current jumped from around 2 to 3 amps to 10, 12, or even 14 amps with Auto SR enabled. And this is where I think the most important takeaway is. Auto SR is not just turn on the NPU and get free upscaling. The NPU itself may be efficient, but the whole process around it still has a cost. The GPU still renders the frame, that frame still has to move through the system, the NPU has to process it, and then the final image still has to go back into the output pipeline. So even if the NPU is doing the upscaling, the rest of the APU and the SOC are all involved and doing extra work. And on a handheld where power and thermal budget are limited, that extra work can take away headroom from the GPU, CPU, and finally lower efficiency. Based on my testing, it clearly changes how the device behaves on the hardware level like no other upscaling tech out there does. It's doing really hard work, and that kind of work is not free. So, is Auto SR worth using right now? Honestly, not yet. At least not on a handheld like the ROG Xbox Ally X, and not as a performance-friendly feature. Auto SR can look really good, but if you care about FPS, frame time, efficiency, battery life, and performance consistency, then based on my test, I can assure you that FSR still makes more sense when it's available. And we also have other options like RSR and Lossless Scaling, which I definitely want to compare next. So make sure you are subscribed to stay tuned on that. Now Microsoft also says that Auto SR can work together with AFMF to improve FPS. But personally, I don't think that fixes the core issue, because if the base FPS is already lower and the frame time is already worse, then adding frame generation on top of it may increase the displayed FPS number, but it can also add extra latency, ghosting, and a less responsive feeling and smoothness. So for me, for sure, AFMF is not really a proper fix if the base frame pacing is already bad. Right now, I will describe Auto SR like this. The idea is exciting, but the performance behavior still needs work. And that's okay, because this is still a preview feature. Using the NPU for gaming upscaling is really a genius and a cool idea. But based on my testing, Auto SR is not the magic performance booster we were expecting. At least, not yet. Right now, it feels more like a high-quality image enhancement feature that comes with a real performance hit. So next, I really want to compare Auto SR against lossless scaling, because that could be a very interesting battle in terms of image quality, performance, frame time, and overall usability. As well as we can compare FSR and RSR. So make sure you are subscribed if you want to see that test. And now I want to hear from you. Were you expecting AutoSR to behave like this? Would you rather stick with FSR, RSR, or lossless scaling for now? Let me know your thoughts in the comment section below. And if you enjoyed this deep dive with me, give the video a like and subscribe to the channel for more tests like this. Thank you for watching, and I'll see you in the next one.